In this video series, I'm going to continue our discussion of multiple linear regression. In past video series, we looked at multiple linear regression as a means of predicting a response variable from more than one explanatory variable, thus expanding on the notion of simple linear regression in which we only had one explanatory variable. Then we talked about covariates and looked at the various ways in which these variables could relate to one another. That is, the explanatory variables themselves might be correlated and, in fact, could be put into different kinds of models in which we use those explanatory variables to both directly and indirectly influence a response variable, or at least be associated with that response variable. In the most recent video series, I looked at moderators and interaction. That is, looking at how one variable could actually influence the effect of another explanatory variable on the response variable. And we found that if that one variable was causing the explanatory variable to affect the response variable differently for different levels of that second explanatory variable, then in fact we could call it a moderator. Not to be confused with moderator, in this series we're going to look at mediators. This again fits under the broad umbrella of covariates and the different ways that variables can influence one another. In this case, we're going to look at an explanation for relationships using a causal chain. So a chain relationship allows us to look at how one explanatory variable affects a response variable, but may affect it because it could be explained or is going through an intermediate variable, which we call a mediator. So in this particular case, and with this particular example, we're using x1 here as education, so it may be proposed that education will influence the length of life. So if you think of x2 not even being involved in this equation, then we would have education is causing varying lengths of life. That is, variation in education causes varying lengths of life. And in fact, we do indeed observe that to be the case, that more educated individuals tend to, on average, have longer lives than less educated individuals. But now what we're going to do is explore that in a little more detail and think about, why is that? Is it the mere fact that you attend school longer? Is that what's causing you to have a longer life? Not likely. So there's probably going to be some explanation. And that is what we call a mediator, some explanation that we can put in this chain in order to explain why there is a relationship between education and length of life. And that happens to be income. And so in this case, what we're saying is that we think that education, let me clear this out here. We think that education is influencing income. If you have higher levels of education, you can make more money. And income is more directly affecting length of life. Now, if you think about it, we could put mediators even between income and length of life, because it isn't the fact that you're making more money that explains length of life. It's what that money allows you to do. That money allows you to buy better medical care. That income allows you to buy health insurance. That income allows you to buy prescription drugs. It allows you to do a variety of things that, in fact, could lead to longer life. Now, one might say, well, but there are even elements of education that might influence the length of life directly. Perhaps more educated people know more about health and about how to live because of their education, and they learn that in the process of obtaining their schooling. And so there could be a direct relationship as well as what we're looking at here, a chain relationship. So more on that in a moment. And now is that moment. We can have full and partial mediation. Full mediation is when the mediator completely explains the relationship of X1 to Y. That is, if everything about the relationship of this X1 to Y, that entire correlation, if that in fact can be accounted for because of the correlation of X1 to X2, if that totally explains the relationship of X1 to Y, is that X1 is related to X2, and in fact X2 then is related to Y. If that's the case, then we have full mediation. But it's often the case where we have partial mediation. That is, part of the explanation could go through the mediator, but the other aspect of our covariation of X1 with Y is that X1 directly influences Y. So in the example I just gave, X1 influences income, which allows us to take advantage of better medical services, which in fact would influence the length of life. But as I mentioned, perhaps X1 also is allowing us to have more education about how to live and how to have a healthy lifestyle and what are the best kinds of foods to eat and whether we should exercise. Perhaps we learn all that in our schooling, and if so, then that can directly influence the length of life. So you can have both direct influences from an explanatory variable, or you could potentially go through a mediator variable. In both of these examples, X2 serves as the mediator. How do we establish mediation? Well, this is a rather complex topic and one that has grown over the years so that so much is being done on the topic of mediation now, and there are so many sophisticated ways to look at mediation. What we're going to do is we're going to go back to the roots of mediation, but I'm letting you know that we're only going back to the roots of mediation as an initial way to understand mediation. So really, you can trace the roots of formal analysis of mediation back to Barron and Kenny. And back in 1986, so we're talking about almost 40 years ago now, they talked about the moderator-mediator variable distinction in social psychological research, and they did that in the Journal of Personality and Social Psychology, and it's just blossomed since then. But in their initial classical approach to mediation, they suggested these 4 steps. Now, David Kenny actually still maintains a website in which he talks about mediation, and if you were to go to his website, what you would find is that very recently he updated the website, and it went from this classical approach to a much, much more expansive look at mediation and the various types of mediation and various approaches to checking for mediation. There is much to be done there. In fact, you could have, and there are, whole classes on mediation. So I'm wanting you to be aware that that exists. But in this video series, which is part of a second statistics course, we're just going to dip our toe into the water, and we're going to learn initially about mediation. And quite frankly, what we're doing corresponds in all that big amount of stuff you can find on David Kenny's webpage. It really corresponds to his introduction, just the first little bit of that webpage. So here are the steps, and I think this is still valuable. I think it's a great starting point for mediation because it really helps you understand the basics, the fundamentals of mediation, and then you could dive into the pool and get deeper into it later on. But in this method, which used multiple regression, we now have additional tools available to us that were not fully developed back in 1986. Structural equation modeling is a great way to look at mediation, and I'll talk just a little bit more about why that is in a moment. But the first step is to show that the explanatory causal variable is correlated with the response variable. So you do that by regressing the response and the explanatory. Let's go ahead and take a look at a picture of this. So we started with this concept of this x1 related to y, but the explanation for that, at least part of the explanation, is because x1 influences x2, which influences y. So step one looks like this. Step one is we want to take a look at x1 and we want to take a look at y, and we want to make sure they're related, because you're not even going to need to have an explanation for why x1 and y are related unless they are related. So step one is to determine that they are related. Step two is to show that the explanatory causal variable is correlated with the proposed mediator. That is, we regress the potential mediator variable on the explanatory variable. So similar to the fact that we need to show x1 is related to y, we also need to show that x1 is related to x2. That is, we can't have x2 as an explanation for the link between x1 and y unless x1 and x2 are related to each other. So we look at that potential relationship and make sure that those are related. Step three is to show that the mediator affects the response variable. Now, you may think that the way to do this is to just look to see that there's a link between the mediator variable or potential mediator variable and the response all by itself, but that's not what we do. Instead, since we're trying to show that x2 is an explanatory link between x1 and y, we want to show that x2 contributes something even in the presence of x1. So this third step involves taking x1 and x2 and regressing y on both of these, and determining then if x2 does make a contribution above x1. And ideally, what we would like to see if x2 really is a mediator is that the influence that x1 had on y is decreased and taken over by x2. So when x1 is in the equation with x2, when we're looking at this chain here, when we're looking at this potential chain here, we start out with x1 influencing y right here, but we want to know then when x2 gets involved that something here is weakened because x2 becomes an explanation for the link to y, and therefore we end up with an effect of x2 to y, yes, but not only that, an effect of x2 to y that's even in the presence of x1 and could diminish what x1 is doing to y. If it doesn't diminish what x1 is doing to y, if we have just as strong a connection of x1 to y, even when we put x2 in there, x2 cannot be that explanation that links x1 and y. There might be other explanations, but it's not x2. So that's the third step. To show that the mediator affects the response variable by regressing both the explanatory variable and the potential mediator, or regressing the response variable on both the explanatory variable and potential mediator. And then the final step is to check whether this is full or partial mediation. And we do that by calculating the partial correlation of the explanatory and response variables after controlling for the mediator. So if you think back to the picture of where you could have direct and indirect effects, let me go ahead and draw that picture in. So we have x1, we have the potential mediator, x1 influencing x2, which in turn influences y, but then we could have this direct effect from x1 to y. If we remove the effect of x2 from x1 and y, and we find out that there's still a correlation of x1 and y, that tells us that there is this direct effect that's part of the influence of x1 on y does not pass through x2. On the other hand, if we remove x2 from x1 and from y, and there is no correlation of x1 to y anymore after we removed x2, then we know that this is full mediation, because this, what we looked for this direct relationship, doesn't exist. So these are the 4 classical steps to look for mediation. And again, I'll remind you, there is much more that we do nowadays, but this is for the purpose of understanding what mediation is all about. And so those are going to be the steps that I take in this video series. And I would refer you to a whole bunch of literature out there, and you could get started on David Kenny's website, but you can expand out from there for research that's done by many individuals who actually spend good parts of their careers focusing on looking at mediation and how to assess for mediation and all the different ways that it could occur. So I told you that I would mention why there are other tools that are better for looking at mediation that maybe in 1986 were not as common, such as structural equation modeling. Well, if we go back to my picture, in which we look at a picture like this, let me clean it up a little bit here. All right, so there's the picture that I drew. What we're doing in these steps with multiple regression, which was available many years before 1986, is we're doing a series of steps. We're looking at, let me change colors here. We're looking at this arrow. We're looking at this arrow. We're looking for this effect. And we're doing this as a series of multiple linear regression steps. If we were using structural equation modeling as one example, we could propose this entire model just like this, and we could look at this as one step, not a series of steps. Now, underneath the hood, there's lots of calculations going on, but nonetheless, we could assess the fit of this model to see if what we theorize about x2 as a mediator and the additional direct relationship of x1 to y fits with the data. So it doesn't require a bunch of individual steps. It doesn't require all of the same conditions for valid inference that multiple regression does. So this is a series on multiple linear regression. I'm bringing mediation into it, so we're not going to get into this more complex method. And it's nice to take the classical approach for understanding, and because we're learning multiple regression right now. So we're going to stick with the multiple regression approach. Be careful to avoid confusion between moderators and mediators. Moderator variables influence the strength of a relationship. They are interacting with the explanatory variable. Mediator variables are explanations for the relationship among the explanatory and response variables. They are the links in chain relationships. So to draw back to pictures that you've seen me draw both in this video and in earlier videos, here's a comparison. When we look at moderation, we're looking at the influence of x1 on y, and we think that there may be another explanatory variable that determines the strength of this relationship, so that if x2 has one value, the relationship between x1 and y is different than if x2 has another value. So in the past video series, I went through this and we looked at how the slopes of the line when we predict y from x1 might differ for different values of x2. Whereas with a mediator, in that example, x2 is a moderator, but as a mediator, you start out here with this, again, with this relationship of x1 to y, and you say, wait a minute, I think there may be some reason for that relationship. I think there might be an in-between here so that x1 is influencing x2, which helps explain why x1 influences y, because x2 influences y and x1 influences x2. That's a mediator. So this is a moderator, and this is a mediator.